All right, we are going to go ahead and get started. It is great to see everyone here. And before we have our last webinar of 2022, I want to say to everyone, Merry Christmas, and hope you have a great new year. And we're going to have some more really interesting topics in the new year. And if you are not already receiving emails from us just on regular announcements, you will definitely want to be notified of the exciting things that we have coming up in January and February. So my name is Jeffrey Palermo. We have a lot of familiar names that I've seen come to quite a few of our webinars before, but a lot of new faces as well. We have a really big group today, and so I want to be respectful of everyone's time. I am a chief architect here at ClearMeasure. I've also been a recipient of the Microsoft MVP Award every year since 2006, and I love learning and teaching and helping all of you out there establish quality in your software teams, achieve stability in your production environments in Azure, and ultimately to move fast, to increase your speed, to have really high productivity, and just have a joy of software development and building things with software. So that's where I'm coming from. For those of you who are joining us for the first time, ClearMeasure is a software architecture company. We're headquartered in Texas, but we are all over the United States. We're a software architecture company that empowers software delivery, enabling in-house .NET teams to be self-sufficient so that you can go fast and maintain quality and ultimately have a lot of confidence running your systems. So that's what we do, from simple architecture advisement to some fractional architecture help to jump-starting certain things. We've been doing a ton of DevOps pipeline inspections, both with Octopus Deploy and Azure pipelines, inspecting and helping improve those, or just jumpstart you and get you going. Been jump-starting Blazor applications, all kinds of new tech, helping people modernize systems, move to Azure, get their Azure bill down, because the Azure bill tends to grow if you don't intentionally look at it, all kinds of things. So our goal is not to do projects for our clients. Our goal is to help our clients do their projects better. Before I go any further, I do want to make sure I touch on the free offer. If you have not already received a copy of my latest book, .NET DevOps for Azure, we'd be happy to send you a free electronic copy. If you just either use the chat or just send me an email, and my email is right there on the screen, jeffrey@clear-measure.com. You can also get a print book anywhere books are sold. And if you are already not a listener to my podcast, then you can find that at azuredevops.show. You can also find the Azure DevOps podcast in any of the podcast directories out there. And that's an interview show. Bring on all kinds of experts around just software delivery, shipping software. And also, 6 months ago, we're 6 months in to a new video show called Programming with Palermo. And so if you have not checked that out, you can search for, quote, Programming with Palermo in any of the podcast directories or on YouTube, or you can find it on the ClearMeasure website and check that out. We go through, we are systematically, again, going through all of the engineering practices that we suggest as part of the ClearMeasure way. And so you can find that there, and also more information about all of the suggested practices that we've included in the 3 pillars of the ClearMeasure way, as you take your teams and make them more effective, increase their quality, stability, and ultimately speed. So if you did not go to the .NET Conf 2022, it was November 8th. If you didn't pay any attention to that and you are interested in the latest version of .NET, I highly encourage you to do that. You can go to the .NET YouTube channel, and you can find lots of great recordings of the full-length sessions. I am basically going to distill down all kinds of announcements from .NET 7 into this format, but I'm also going to talk about it from an architectural perspective. Yes, there's all kinds of features. There's all kinds of tech that's coming out. You may want to use this library. You may want to use this framework, this feature, and all that. And that's great. I'm going to tell you, and I'm not going to tell you. You're smart. I'm going to suggest some things to think about from an architecture perspective, and I'm going to highlight some of the things that were particularly interesting to me and have been that might change the way you make architectural decisions in your software. And when I talk about architectural decisions, I'm talking about the long-lasting decisions. I'm not talking about use this method or this API or whatnot. I'm talking about the big decisions that truly up-level the software engineering team. So that's the mindset that we're going to go through here. And so let's get into it. We've got a lot to cover and not a whole lot of time to cover it. And so, by the way, as we go into it, just hit up the Q&A window if you have a question. I'm pretty good about working in the questions. And as we get into the first topic, I want to understand kind of the distribution of the group that we're working with. So we're going to launch the webinar poll, and just to let us know kind of where you're coming from, what version of .NET are you currently using, and is your primary job a member of the software team where you're coding all day, working on the software, or are you the lead of that team, or do you help lead that team, or are you not on the software team, but you're in company management and your company has a custom software team? So just we'll give that a little bit of time here as people let us know what version of .NET you're working on, how we're distributed here, because we have a ton of people on this webinar. It's really exciting. I'm really glad as we kind of roll into the second half of December and everybody starts thinking about Christmas and gifts and all the hubbub and Advent. All right, looks like the results are almost stopped changing. We'll give it just a few more seconds here. Okay. All right, let's go ahead and end it. And just so you guys can see kind of where we're laying at, we got a lot of people that are using .NET 5.6, a lot of people that have jumped on .NET 7. And of course, you've got multiple applications. You're using a lot of everything. So fantastic. Well, let's get into it. All right, .NET 7 at the high level, it is a short-term release. That means it's going to be supported for 18 months, and then they're going to roll into .NET 8. And 8 is going to be the long-term release. It is a seamless upgrade from .NET 6. It really is. Any kind of compilation changes or breaking changes in libraries are quickly and easily fixed. The huge theme for .NET 7 is performance. That's the huge theme as far as the SDK goes and the compiler and the runtime. The huge thing is performance. A lot of focus on ARM64. So if you've been doing some work for ARM processors, then this will be interesting for you. Now, the mono perf improvements greatly affect WebAssembly, Blazor WebAssembly, the new WASI experimentations that are running, so that perhaps they can get older WPF and WinForms applications to run launched from a browser running in the WebAssembly runtime. So we'll see if that is somehow possible, but they're working on that. And that also affects MAUI. And so the mono perf improvements are huge. And of course, the ARM processors that go along with it. We're going to highlight some of the C# 11 features that go into it. Generic math, static virtual methods, and then there's some tooling. There's a first rev of some container tooling built into .NET Publish, .NET.exe, that they're working on, but they're promising future refinements along the way as they release, .NET 7 and then 7.1 and all these patches. So and we're gonna really highlight containers in a big way, because Azure container apps in Azure is just as big of a deal as a new version of .NET and a new version of Visual Studio. So Actually, we didn't have a new major version of Visual Studio. We're still 2022. But all right, that's the highlights for .NET 7. Azure Container Apps. I'm highlighting this big time because there was more tooling, more support that came out. This is Azure Container Apps are a year old, but the tooling has been getting better, and it's been getting easier to use it with .NET. So Azure Container Apps, if you're not familiar with it, never played around with it, it is a service that wraps Kubernetes. It is just like Azure App Service for wrapping a Kubernetes pod running on a Kubernetes worker node. And I'll talk about those concepts later on. And some of the key features is you can scale, as opposed to app service, where you can scale on a few different rules, but it's kind of coarse-grained. With Azure Container Apps, you can scale down to idle or scale down to nothing and take it offline, or you can use any metric under the sun that you want to scale with. The key here is the Kata or Kata scalers. Those are kind of part of Kubernetes, and Azure Container Apps is wrapping Kubernetes. And so one of the Kata scalers is an Azure Monitor metric. So I think most of you, if you are not emitting Azure Monitor metrics straight from your application and then looking at it in Application Insights or whatever APM you're using, you want to be doing that. And when you do that, you can literally have C# logic determining the metric by which you scale up the CPU capacity or the memory capacity or the number of Azure Container Apps. It also has a secrets dictionary built in. It runs off environment variables. So those are the high points. We're going to get into that. All right, so let's first start out with some of the things I want to highlight in C# 11, part of the .NET side. And I'm not going to talk about all the different features. Again, we're thinking from an architectural perspective. These are the big things. If you're running a software team, you want to equip your engineers with certain patterns, certain technologies, certain decisions, so that they can be world class. And so, highlighting a few that fall into that category. This is one. The required initializers. You can see on the screen the required keyword, where like last name, you can get it and you can set it only on initialization, only on the constructor or only on the initializer statement. And the compiler cooperates. If you mark that as required, then you cannot use the property initializers unless you initialize last name as well. So across the board, across your entire code base, you're going to see a lot of simplification, because if you needed to require some of these parameters, then you had to use constructors everywhere, and you didn't have the flexibility of using property initializers. And so now you do. And so you're going to be able to simplify code just a little bit more. So that's one of those little things that is, in my opinion, is going to have a pretty significant impact across all of your code base for data transfer objects, for commands, command objects, query objects, event objects, all those simple little objects that carry data, including your entities that are persisted to storage. So that's one feature. The next one is absolutely huge, and this is static interfaces. For the longest time, interfaces only could include instance methods and instance properties. You could not have any kind of static. And so when you had, therefore, there was no global abstraction. You have like int.parse. Well, parse happened to be on int, it happened to be on decimal, it happened to be on short and ushort and all kinds of primitives, but that was just a naming convention. That wasn't actually an abstraction. Well, now you can literally create an interface with a static abstract parse method. And if your class implements that interface, then it also has to implement that particular static method on the type itself. So interfaces have now been elevated from just instance ramifications to the entire type, both static and instance. So that is huge. That is absolutely huge. Okay. And by the way, I'm gonna go into this a question, Nicholas. What's your experience with the cost of ACA? It seemed to me that ACA, Azure Container Apps, was kind of expensive. All of the Azure services do have a cost, but and I don't think the dust has settled on it. But Azure Container Apps is very much in line with the cost of app service for what you're going to get for the different cost. However, the huge difference is if you have periods of seldom use. For instance, if you have departmental applications where your employees are the ones that use an application and very, very little usage happens in the middle of the night, you can scale it down to absolutely idle and save a lot of your money instead of leaving your app service server running all the time. So a CPU in Azure is going to cost what it costs, and a gigabyte of RAM of memory is going to cost what it costs. But Azure Container Apps lets you save by giving you the power to be more granular with how much you have provisioned at any given time. All right, so I hope that answers your question, Nicholas. I appreciate you putting that in the Q&A. Okay, another C# 11 feature is pattern matching with I number of T, and well, pattern matching is, they've put that out in 10, but it's been enhanced with these different interfaces. So I number of T is new for .NET 7, and it means that you can create all kinds of numbers. For example, day of the month or day of the year. That's a very specific number. It's you think, oh, it's kind of based on an integer, but it can never be negative. So then you might think, well, maybe it's an unsigned int, because unsigned ints can't be negative. But it also has a much lower upper bound. Well, you could drop it down to a short, but the upper bound of a short is not what you want. You want 365. So you can make your custom numbers, and you can have a richer type system and have the framework treat, and the syntax of C# treat it like a number. And so there are so many developers out there, and the number of developers has basically doubled every 5 to 7 years for the last 20 years. And so early discussions with .NET came out about it being an object-oriented language and all that. What has ended up happening is the .NET framework itself and all the libraries, yeah, those are object-oriented, and some of the libraries implement abstractions better than others, but developers don't universally leverage the power of object-oriented concepts uniformly across our industry. And so this is one of those niceties, one of these abstractions, along with static interfaces, that makes it super, super easy to create your own very specific number types. And when you're using pattern matching and enumerating and creating switch statements and whatnot, you see that anything that you have, like day of the year, which is basically 1 to 365, you could have literally T.0, and you could iterate over, and you could do addition, all kinds of stuff. So that, I think, is going to have some pretty interesting ramifications, because all of us have numbers in our code bases where we're using kind of a regular generic type, and then we're just having logic and exceptions and methods that try to give some constraints about its bounds and how it can be used. Well, now we can create a custom number type that has all of that baked in, and then the rest of the application has less duplication because it's using a first-class type, not a int that's kind of wrapped with some constraints. Okay, last C# 11 feature that I'm going to highlight is string literals. And this is something that can simplify the code bases quite a bit, and it'll probably cause you to amend your coding standard, and you'll look for these when you do pull request inspections. But when you create a string literal, You've been able to do multi-line string literals for a number of years now, but you see the multiple quotes. Well, if we use tabbed indentation for a string literal, then that was actually part of the string literal. But by the number of quotes we start the string literal with, it lets the compiler know to ignore a certain number of spaces or tabs. So you can see the little gray line up and down. That's Visual Studio giving the hint that up until that point, these are going to be ignored. So the open the less than sign element, that's going to be the first character in the line because we have 4 quotes. And if I wanted to indent that one more, then I could start it with 5 quotes and end it with 5 quotes. And so a lot smarter string literals so that you can indent it with the method body. Again, this is for readability of the people that are going into a code base and quickly scanning the code looking for an understanding. So that one right there is super nice because string literals have been clunky for a long time. And so for those of you who lead or manage a software team, this is one to kind of get your people trained up on and start using it. And that's another element of simplification. All right, let's start going into the runtime. I want to start off with ASP.NET Core. And this really is it's one of the big dogs. It's one of the big dogs inside .NET. It can run so many things. You got this, and then you got MAUI, and then you got the desktop variants of WinForms and WPF. But ASP.NET Core, it came from active server pages in the late 90s. That's what ASP stands for. And even before active server pages came around, when the IIS server version 1 or 2 came with the code nugget, the less than %, and then active server pages kind of inherited the less than % sign. And now, we're using less and less of that tag, but it has a long heritage going all the way back. However, within it, you can write these UI-based web applications. You can write web services that have no HTML in them whatsoever. You have unified middleware, these pipelines of logic that can direct a URL to go to a certain place. You can mix MVC with Blazor, with Razor Pages, with web API controllers for HTTP APIs. And then there's all these extensions that work across the board everywhere. Dependency injections baked in. The configuration has all kinds of options, whether you want to get your config from an app settings.json file or get your config from environment variables. It's your choice. And then it's still called ASP.NET Core, but one thing that this part of .NET does super, super well is just run little tiny worker services. If you're going to add a microservice or 2 or several to a particular system, then you're just going to create a worker service, which is going to run as an ASP.NET Core process. Doesn't have anything to do with HTML, doesn't have anything to do with web services. Maybe all it does is sit there and listen to an Azure Service Bus queue, and whenever a message comes in, it does something. Or maybe it just sits there and listens for a SignalR message to come in, and then it calls somebody else and does something. Or maybe it does expose, an HTTP API. But either way, worker services just sit there and do something and can be triggered by all kinds of interesting things that happen. But from an architectural perspective, the big thing that I want to convey is that it's optimized for Linux. Okay, it works great on Windows, but going forward, so much of this is being intentionally designed and tested for Linux. And I'll talk about that more when we get to Azure Container Apps. I don't want to scare anybody away that is an entire Windows ecosystem, because so am I. I mean, I'm not a Mac guy. I'm not an Apple guy. I don't have a Linux desktop. I have a Linux VM, and I don't proactively run Linux VMs historically. My entire career is Windows desktop, Windows server, and in Azure, of course, all of App Service is all Windows compute. Now you can run some Linux and App Service, but if we're running .NET applications, Windows has kind of been our go-to. And ASP.NET Core and all these things run absolutely perfectly on Azure App Service. They do. And you know what, 80%, it's a super high number of all the custom applications in Azure are on App Service. That's the big dog. And most of that, for Microsoft Shop.NET developers is Windows. But with Azure Container Apps, again, which we'll talk about more, so much is being optimized for Linux. Kubernetes does not work on Windows. Kubernetes is a Linux framework for containers, and Azure Container Apps runs on top of Kubernetes. So by definition, all the stuff you see with Azure Container Apps, translating that in your head to Linux runtime. But if you're running on .NET 7 and you don't have any kind of historical Windows dependencies, then you're natively platform agnostic anyway. You don't care if it runs on Windows and Linux. You just don't care. Okay. So let's keep going. One of the huge things with .NET 7 to be aware of is performance continued to increase. .NET 7 overtook Go in this past round for some of the benchmarks, but .NET 7 is the top dog right now when it comes to web service requests per second. So that should make you feel really good from investing in this and training your team more on this, because 10 years ago there was a lot of talk about Node.js, and it was gaining ground. And from a performance perspective, .NET was kind of middle of the road, right in line. But now .NET 7, from a performance perspective, absolutely blows everybody away. So that's really encouraging. And JSON, working with JSON, that also has huge improvement over .NET 6, which is already fast. So .NET 7, king of the hill when it comes to web performance. So that's really encouraging. All right, I'm not going to go into all these features of ASP.NET Core. Here's a smattering of some of the new things that came out. Rate limiting is really interesting because whether it's an intentional denial of service attack or whether one application just goes haywire, and let's say we don't want to scale a particular web application up to infinity. We just want to let it run on 1 or 2 CPUs and say, you know what, whatever it can do in that capacity, it can do. Well, rate limiting is our friend from that. Also, output caching is going to limit the CPU usage. Route grouping, for those of you who do tons of web services, that's going to be your friend. And then on the Blazor side, custom elements is going to be huge for you. And the data binding, there's now first-class events for when someone types in a Blazor text box, and you can run your C# code as a response to someone typing a character in. So that's less interop with JavaScript having to do client-side events in the browser for those Blazor applications. And I'm gonna let you do your own research. Go back to the .NET Conf sessions to see more about this. But I want to just stick to the high level, the really big ones, in my opinion, that make a difference architecturally for you. I'll highlight the Blazor, some of the Blazor things. Quick Grid is really interesting because it's that virtualized infinity-sized grid that can just stream things instead of having to go to a Radson control or Infogristics or any of the component vendors. There's going to be one of them kind of built in for Microsoft that can do data virtualization. I talked about the bind enhancement. This is kind of what it looks like. After someone changes a character, you can run some code. After someone sets a value, you can run some code in a C# method. Those are interesting. And then you got navigation locking to make sure that no one navigates away from your application unintentionally without some sort of warning. So you have a hook there. You can run some code when someone's about to navigate away, and then you can block that navigation if you so choose. We talked about custom elements, loading progress, which you'll see in the demo app that I show you real quick, and then of course some performance. So lots of good things I'm not going to touch on. I just wanted to highlight those. On the MAUI side, they've been doing a lot of work with MAUI. If you are looking for the write once, run anywhere, from Android to iOS to Windows desktop to Mac desktop to web in Blazor WebAssembly. Then .NET MAUI is going to be really interesting for you. This round was tweaks. Okay. .NET 7 round for MAUI was not anything groundbreaking. It was they're filling in the gaps. They released it, they went GA. It's not yet that canonical version 3. They're still working on making it a complete package. They're still working on tooling. The iPhone pairing for the Apple restriction that you have to compile on an Apple device in order to actually run it for iPhone. That's a little bit clunky still, but lots of great work. And if you need to target those environments, it is already good enough for you to do that without doing a native iPhone app and then a native Android app. And if you have Xamarin, if you've been doing Xamarin already in the past, then this is a straight upgrade improvement for you over Xamarin Forms. But the .NET 7 round for MAUI was incremental improvements. And you can see devblogs.microsoft.com/.net/.NET MAUI .NET 7 for all those announcements. All right, let's get into the exciting part, Azure Container Apps. Ian made a comment. Interesting on your graphic of all the good stuff that database storage doesn't appear. There's so much out there. I really did highlight the things that I thought were significant new events in this .NET 7 wave that I thought everybody needs to be aware of. So yes, I did have to pick and choose, and so I appreciate that comment. All right, so Azure Container Apps, they are serverless. You do not have control over the VM under the covers that is running it. And it's kind of designed for microservices. Now, again, microservices is one of those words that even the people who are doing it are still trying to understand what the heck it is. When we really talk about microservices, we're really just saying, you know what, I'm intentionally going to break up my application architecture into multiple things that are running in production instead of running all of it in the same process and then just scaling all of it together. So instead of running every single web service and every single web screen in the same application running in app server and then just giving it more instances, instead we're going to say, you know what, I'm going to take a group of these web services and I'm going to actually run them in an application of their own. And I'm going to take this web application with these screens and put it in another one. And I'm going to take this these queue handlers and I'm going to put these queue handlers in their own little application, and they're just going to sit there as a worker service, and they're going to listen for a queue, and they're going to process all the messages that come in on that queue. And when you do that, then you can analyze the CPU and the memory usage of all of them independently, and you can scale each one of them independently. And if you decide that all of them need to actually have a different maintenance schedule, you could actually build, test, and deploy independently if you then break them out into their own Git repository. So there is a spectrum here for microservices. And so I think the people argue all the time, but if you want to step in the direction towards microservice, I like to translate in my head autonomous, totally independent services, because obviously you don't want to go to the epitome of micro. It's insanity if you have one web API with one method packaged in its own deployed process and it's running. And if you do that across the board, and we've already seen some case studies where someone ends up with hundreds and thousands of microservices, and then instead of a development complexity problem, you just translate all of that to build, deploy, and operations complexity. And it's a nightmare on the operations side. So everything is a balance, but to step towards the direction of independent autonomous services, you can take your existing Visual Studio solution and you can maybe break out another application, you wrap it up and deploy it. And then you realize, you know what, one of these really does want to be deployed on an independent schedule. Let's take that particular thing and let's sprout it over into its own Git repository. Because only when you have your own Git repository for something with your own DevOps pipeline of builds, automated tests, release candidate packaging, progression through pre-production environments, and then into production, only when you have all of that do you truly have an autonomous, independent service or application. Until then, you just have a multiple deployed services that are a part of the same logical application from an architectural perspective. So that's my guidance for you, because I know that every single team that I talk to has some questions about what is a microservice? So just in your head, say autonomous, independent, smallish application or focused application. Okay. All right. And so let's kind of get going into this. Let's go to the next slide. All right. From a Microsoft perspective, they are positioning Azure Container Apps to be your next hosting solution for your custom .NET applications. Now, for the world, they're positioning it to be the application for everything, even people on other platforms, and that's perfectly fine. But for .NET 7, you can build kind of whatever you need to, right? We've already talked about web API, web applications, event-driven processes like queues and worker services. So you can pretty much build whatever you want to, and you have an infinite number of ways that you can choose automatic scaling. So you don't have to go into Azure either with command line or the portal and give yourself more horsepower. So that's how Microsoft is positioning it. They are investing in Azure Container Apps big time. And so, just like we've had a good 10-year plus run where Azure App Service was basically the default way to host your application in Azure, unless you had something very specific. It was kind of like Azure, you have Azure App Service and you have Azure SQL, and then you have some other stuff if the application warranted it. I think this is setting up where for the next decade, you're going to have some things running in Azure Container Apps. Then you're going to have Azure SQL, and then you're going to have some other stuff, whether Azure Storage, Files, Tables, Azure Service Bus, SignalR Service, and in my opinion, some of the things where it was really tempting to deploy as Azure Functions may be simpler deploying it as a container app instead. I think the dust needs to settle on that until we really understand what things with container apps still are better as a function and which things are better just as a container app. So, but anyway, the way that Microsoft is investing in this and the proven success of the Kubernetes model, this is probably sets us up for the next decade of the normal way to deploy applications. And so some of you are saying, oh, I don't want a new normal way. I'm comfortable with the way I have it. Well, again, if you're leading a software engineering team, you need to understand the benefits that this provides so you can decide whether to wait and see or whether to move something or build something new for a container app. And I hope to shed some light on that for you. So I do want to highlight again, even with container apps, your basic DevOps flow does not change. This is a architecture poster that we've used for a long time here at ClearMeasure that highlights the process, the DevOps process. By the way, if you don't have a copy of this and would like a full, this is the full poster. It's meant to be sent to a print shop 2 foot by 3 foot. If you would like a high resolution PDF of this poster, then you can just use the link in the chat, or if you're seeing this after the fact, you can send me an email. I'd be happy to send that to you. But this is just the top third of it, and it highlights how you have your Git repository, and then you have your build server, which does an integration build And then off of the integration build, you package up release candidates and store them in a package management service. Azure Artifacts is your NuGet server. It's your package management server. And then whether it's Azure pipelines flow through to Octopus, or for the simpler stuff, if you're using Azure pipelines, for the multi-tenant environments and the more complicated things, you're using more of Octopus deploy. Doesn't matter. The process is the same. And the number of environments is important. You will never have fewer than 3 deployed environments, because there are 3 distinct types of environments. Production, of course, you need at least one of those, but you can have multiple production environments. That's perfectly fine. Backing off from that, you need a environment to do some manual testing. And lots of teams have multiple environments to do manual testing. You can call it whatever you want. You can call it UAT, staging test, all kinds of names for a manual test environment. You need at least one. And then backing off from that, you need a TDD environment, or whatever name you want to give it. It is a automated test environment. And you absolutely need at least one of those. As soon as you have a new build that's packaged up and released, you want to have your automation automatically deploy it to your test automation environment, so that your full system test suites can run tests against a fully deployed instance of your whole application. And by the way, if you're segmenting for microservices, every one of your autonomous independent services needs a DevOps environment, a DevOps pipeline. Okay. And so that's some of the complexity about moving to the microservices pattern, is you need to already be good at automated DevOps. If you're not already good at automated DevOps with a multi-process single Visual Studio solution application, then your sequence should be get completely automated from a DevOps perspective, flesh out that pattern for you and your team, then sprout your second Git repository with a DevOps pipeline, kind of using your same pattern. And we do so much of this advisement for customers, because the pattern is there, the knowledge is out there. You just need to put it in place for yourself. Okay, so Azure Container Apps. I'll pause for a question. Sunbar says, is event-driven framework a requirement or a prerequisite for microservices? No. Again, a microservice is just an autonomous, independent process or application that's running out there, and it could sit there and it could host a number of web services. You could split up a website into independent, you can call it microsite versus microservice, whatever terms you want to use. One pattern that I really love is sprouting an admin site off of an application. When you realize that you're starting to implement role-based security somewhere, look at it, and it may be a simpler solution to instead realize that, you know what, there's 3 particular screens that most users should not have access to, and only the quote super admins should have access to these particular 3 screens. Therefore, we need to implement user roles, and therefore we need to have this basic permission, and therefore our navigation system has to have the intelligence of that solution. So, and we need to block normal users from going to these 3 screens. Well, that's a lot of complexity to put in there. Okay, so anytime you're going to add a piece of complexity, it needs to have a return on that investment. Well, sometimes it is a simpler solution to say, all right, let me take those 3 screens, let me create web application number 2. All right, whether it's MVC, JavaScript SPA on top of web services, or the what I would consider the new normal .NET application, Blazor WebAssembly. Create a second web application for those 3 screens, and you can't even log into that second application unless you are a super admin. And so right off the bat, no more role-based security, no more permissions. You have now a second application for the admin site, and it logs in but it only even authenticates if the user has a tag of super admin, some column in your user table or a particular claim in your identity server, whatever it happens to be. And so that second web application with 3 screens, guess what? It's a microservice, right? It's an autonomous, independent application with its own Git repository. Now, if you don't want to quite make it autonomous, don't want to make it a microservice, you don't necessarily have to. You could leave it in the same Visual Studio solution, not make it totally autonomous and independent, but just at runtime, independently deployed. And therefore, you still have one integration build, one DevOps pipeline, and that's a fine solution as well. So don't feel bad if you don't understand all the hype about microservices, because microservices is not the new normal for the majority of teams out there. It is another tool in the tool belt, and you will know when to reach for that tool when the other solutions don't seem to fit, because it comes with some of its overhead. You have to have a new Git repository, a new automated DevOps pipeline, which includes new deployment. And so now you have 2 applications that you're managing and operating that flow on independent schedules. So it's a real important decision, okay? And when you need it, you need it. The pattern's there, and it's great, and it's awesome. But if you don't need it, well, then it's just kind of overhead that slows you down and doesn't actually provide any value, all right? You get the return on investment when you're already moving slow because you haven't implemented that kind of pattern, and implementing actually speeds you up because it took out some new possibilities. All right, so thanks for that question. Another question from Nicholas. Were you the guy who said to put each of those environments in separate repos? Were you the guy? Well, I'm not sure about that. There's a lot of guys out there. Environments in separate. Well, you put code in separate Git repositories if that's what you're talking about. So if you want something to be autonomous and independent, the full spirit of the genesis of the microservices pattern, then yes, you would put that code in a separate Git repository, and then therefore you'd have a separate build and DevOps pipeline. I hope that answers that question. All right. Let me do a little bit of demo, and then I'm going to come back. There's a few more questions. Okay. So when it comes to Kubernetes, when you look at Kubernetes documentation, you're going to see a few things. You're going to see the Kubernetes, the overall cluster. You're going to see Kubernetes worker nodes, and then you're going to see pods. Okay. Just remember that a container app wraps a Kubernetes pod and is the unit of scaling and network segmentation. So everything running in a container app, which by the way, you can have many Docker containers. Therefore, you can have many .NET applications running as each in their own container in a single container app, just as you can have many web applications running inside of a single Azure app service. Okay. But an Azure app service has an Azure app service can actually have multiple URLs, one for each web application. A container app has a single URL, which I'll show you. And so you need to manage your ports because you don't want containers stepping over each other. But a container app is a Kubernetes pod, and it all scales together. And then a Azure Container App environment is the virtual network boundary, whereas the container app has a known IP address. So just that's the kind of correlation to Kubernetes. All right, so I'm gonna just finish this one and get into a demo here so that you can kind of see firsthand. Going to move over to Visual Studio and Azure, but Dapper. If you've heard of Dapper, I'm not going to talk about Dapper today. If you've heard of Dapper, it literally is embedded in container apps, and it abstracts away ports and networks so that if you need to call a web service on another one of your applications that's in the container app, then you kind of have a synchronous service bus or network locator where you can call it, and Dapper does the translation. It's almost like Dapper is DNS for your applications. Dapper is the registry where you can call a service based on its name, and Dapper knows where it is because you got all these containers running around. All right, but we're not going to talk about Dapper today, but just to kind of whet your appetite. And on the costs, okay? So a CPU costs what it costs, but you can basically run a full CPU's worth of load for about 1/3 of a month before you start paying anything. So for testing and doing development, you got a pretty nice grant on the free side. And so you get free CPUs, you get free memory, and then you also get free HTTP requests. So you get 2 million. That basically, if you were to do 3 web requests every second for an entire month, that would be 2 million. If every working hour of 5 days a week, you could be running 3 requests every single second while you were at work for an entire month, and that would be your 2 million of the free grant. And then above that, you get charged per request. For the memory I've allocated and for the virtual CPUs you get allocated. So again, the pricing is based on CPU and memory. So it's going to be comparable to having the same capacity of app service running all the time, but container apps are meant to scale and be elastic. So you have a much better chance of only paying for what you need. Whereas with app service, we tend to over allocate and leave it allocated even when the capacity isn't needed every minute of every hour. So let me switch here and now go to Visual Studio. Here's an application I'm going to be working with, and here is what I'm going to show you as a container app. So I'm in Azure Container Apps. I've already pulled up the application, and it is just an easy template with one additional navigation, and it's just a sample. We're working on a simple church bulletin for announcements at church. And so this is actually being pulled from an Azure SQL database. So this is hard-coded data. The template does hard-coded data, and this is actually pulling from a database. Okay, and this application, the code is in GitHub. So feel free to grab this. I'll put it in the Zoom chat. Feel free to grab the code and use it as you see fit. It's got the Docker file. It's got a private build. It has the Azure Pipelines YAML configuration. It also has the GitHub Actions integration build integration. The build, though, I'm looking at is in Azure Pipelines, and so we have a build that has run 1.1.46. So remember that. And if you care, I'm not going to go into all this, but if you care about proper builds and multi-levels of automated tests and the configuration for getting code coverage metrics just saved for you in Azure Pipelines, then I encourage you to go and grab this code and steal everything that's in the build PS1 file. And of course, I have it open here so that you can see. Of course, you can take this build script. I've been using this template, and at ClearMeasure, we use this template all over the place because you don't have to create a custom build script. You see there's tons of just properties at the top, and then the functions are the same. We need to clean up from the last build. We need to compile. And so don't figure out all of these command line switches yourself. Just take this template. These are the command line switches you need. Treat warnings as errors. You put that right here, and it's just going to happen automatically. You have your unit test, you have your integration test that run. There's 2 command line switches that make the code coverage happen. You have collect coverage right there, and then you have the type cross-platform code coverage. And then, of course, in the Azure Pipelines YAML, you wire up the code coverage. And then full system acceptance tests, running that we have a Selenium test library in here. And then we actually are creating our database locally, and we're packaging it. We're using Octopack to create some nice NuGet packages. And we actually have our private build and our CI build right in here. So if you don't have that running from an automated DevOps perspective, just go ahead and steal this code and use it. And I hope that helps. Okay, so we run the build here. Oh, that was the previous one. With .NET 7, it's pretty easy to upgrade. You can either do Alt-Enter, and you can change it from .NET 6 to .NET 7 right there. But what most of you are going to do with an existing application, you're going to click on a particular project. You're going to see that it says .NET 6 or .NET 5, and you're going to change it right there. Then you're going to see that some of the package references don't start with a 7 that are kind of built into .NET Core. And you're going to have to change them there. And you're just going to go through all your CS proj files, and that's pretty much all you got to do. And then just compile it and probably walk through some of the steps. Or for NuGet packages, over time, you're going to go to update, and you know what? There's going to be some of your packages that are from .NET 6, and you're going to click on it, and it's going to, oh, .NET 7 is available, and so you're going to do an update, or you're going to select all packages and hit update. When you do this, if anything pops up in your consolidate tab, go ahead and take care of it. That means one of your projects is using a different version of a NuGet package than a different project that's using the same NuGet package. So anytime something pops up in your consolidate tab, just go ahead and take care of it. All right, so it's super easy to upgrade to .NET 7. Now let's get back to container apps. All right, so we have our container app here, and it's running. The application is running here. So actually, I am going to, just because I know all of you probably want to do this, I'm going to copy and paste in the URL to the chat, because you probably just want to click on it, make sure it's real, right? All right, so let's go here and let me walk you through this. When you create a container app, you put it in a resource group, but you have to actually have a container app environment. So I'm going to click over to the container app environment, and this is a resource. Think of it like a app service hosting plan. You have to have an app service hosting plan, and then you have multiple app service environments in it. The managed environment is akin to the Kubernetes worker node, okay? Every container app that you put inside of a container apps environment is going to be working is going to be running on the same Kubernetes worker node. That means it's going to be in the same Kubernetes cluster, which means it's going to be in the same Azure data center, which means it's going to be in the same Azure region. Okay, so you cannot have container apps in different Azure regions, but think that they're going to be in the same container apps environment. Okay, because that's the way that they work. Because the container apps environment is your network boundary. That's where you can kind of control more firewall stuff, or if you need to have VPN or express routes set up. The container apps environment controls all the networking. Okay, so you got to have one of these. Container apps go inside of this. So let's go back to where we were. So we have a single container app now inside the container apps environment, and you have your URL right here. So you're going to get to name the first part, and then Azure is going to just kind of give you a funny thing like Icy Moss. Azure gives that to you, and then a little hash. It looks like it's part of a GUID, just to make it unique. I'm running in South Central, and so you have .South Central. All right, let me go down to secrets, which is something I want to highlight. This is where you show your things that you want to be known only to you. Now, Octopus Deploy and Azure DevOps, when you put a secret in there, not even you can get it back. But with Azure Secrets, if you own it, if you're the owner, you can get it back. Okay, but it is encrypted, and you can get to those secrets. All right. Now there is a continuous deployment tab here where you can specify either a container registry or a GitHub repository to do auto deployments. This is for playing around. This is not for team development. Okay. Now you may find a place where you have a pretty static website or something super simple, and you want to say, you know what, let me just hook it up here. Okay, there's scenarios where you're going to do that, but most of the time you want to go through the formal DevOps pipeline, and you don't want to use this built-in one. I do understand why Azure puts it there to make it easy for people to deploy code with all kinds of different methods, and that's fine. I just want you to know that that's my opinion on it. All right, custom domains. You can register your own DNS, your own custom domains. You can get your URLs exactly like you want to, no problem. All right, let's go to containers. And by the way, I'm not showing you Azure Container Registry. You do publish your containers to Azure DevOps Registry. And by the way, we're running over our time just a little bit. I'm going to finish up quick. For those of you who would like to stay, I want to finish showing you through this, the high points, because I think this is important. Inside our Visual Studio solution, inside our Git repository, I have a Docker file. This Docker file, this is all the Docker file that you need to take a Blazor web application. By the way, Control F5, just so you know that this application is the same. This is a Blazor WebAssembly application, and this is all you need to, there it is. It's the same application, okay? So UI.server, that's what we're running. And in the Docker file, you notice that our entry point is .NET.exe with an argument of the path to the entry assembly of our application. Super simple. And this is a diagnostics. This isn't even necessary. This is just doing an ls on the app directory. So we are using Microsoft's image of ASP.NET 7. Okay, we're exposing port 80. We're declaring the /app directory to be our working directory, and then we're copying a arbitrary local directory into it as we build the container. And if you look inside Azure Pipelines.yaml for the term built, you can see that we are grabbing the NuGet package in our step for downloading the NuGet package. We're grabbing the NuGet package and we're extracting it, same as a zip file, we're extracting it to a /built folder. And next, we call Docker, we tell it this is the Docker file to use, and we give it a service connection that we've set up in Azure Pipelines with the build number for the tag. And literally, that's it. We have a .NET application. We unzip the zip file. We have a directory of stuff. It's the same thing that we got from .NET Publish. And we copy that stuff into the container, into the app directory. And literally, if you want to copy this Docker file and just drop it in there, that's all you do. You don't have to have Docker Desktop. You don't have to have all this other Docker tooling. That's it. Okay, so please grab this Git repository and go to town. All right. Okay, so notice that the image tag, there's two ways to do image tagging. One is to just have the build number, which I prefer, or if you have older applications that have configuration built into configuration files, then you're going to have to create per environment containers, because containers are immutable. And if the configuration is inside the files, then you have to have environment specific configuration in the container. All right, I'll show you a different container app right here, where if you can refactor your application to use environment variables rather than app settings.json, then that's the way to go. Because then, I'll show you, the image tag is literally just the version, and the configuration comes from environment variables. When you do a deployment command line, you're actually creating a new revision, okay? And you can have multiple of these going. You can split traffic between two versions, but you're going to create the revision. So you click in here. Actually, let me click create. And if you haven't ever seen scale, I'm not going to mess with this. You can specify how many you want. There's an upper bound of 30 of these replicas. Again, you're running inside the same pod, so pods can't be infinite. All right, go to containers, new revision. And this is how you do it. You click, if all you want to do, and I'm doing it with the mouse, but of course AZ command lines do everything here. You go into one of them, and we can go down and we can give it more horsepower right there. Or we can add an environment variable. You do this command line, whatnot, and your application just reads environment variables as its configuration with the .NET middleware. And when you create a new revision of this, it's going to do its pretty much like deployment slots, but you can't pause it. With deployment slots, you could deploy it, then you have a URL for the slot, then you could check it out, and then you could swap the slots. This does the same process, but you can't pause it between swapping the slots in the same way. You do it, and behind the scenes, it gets it spun up, and then it automatically switches the DNS, okay? All right, so that's how that works. It's pretty darn simple. It is Linux, and I have a little helper / version. I think everybody should have a web service that just gives them back what version of the application you're running. So 1143, and let's click on here. Let's look at the container that we have running. The tag is 114. Oh, I need to refresh. Or is it? Oh, I'm on the wrong one. On the wrong one. Let me click on the right URL. All right, so loading the new Blazor template. All right, it had scaled down to idle for me. All right, 4.6, version 4.6. There we go. That's another DevOps trick. You always want to embed your versions. All right. So, okay, a lot of information. I wanted to give you the architectural implications of this latest version of .NET 7, which containers are a huge part of this release. A lot of information to go through. I'll finish with the questions as we go through here. Pull up. Okay, so the next question is, do all 3 targets have to exist, run continuously? That sounds like expensive. I think what you're talking about is all 3 environments: production, manual testing, and the TDD environment. Well, anytime you have a DevOps pipeline, you're going to have environments that you're using. In Azure, you can shut down the environment anytime that you're not using it. So no, they don't have to run continuously, only when you need to use them. So thanks for that question. Next question we have is, I totally agree with the separate application idea, Nicholas. Every application needs at least 3 roles based on accesses: user, super user, developer. Okay, awesome. Thanks for that comment. And looks like we have one more question here. Are you planning on covering Dapper at some point in time? Yes, Matt. I do plan on it. It's being built right into container apps. So it's not one of those things that Microsoft is positioning as, oh, here's a useful library if some people might using it. It is positioned as a first-class citizen in Azure. So yeah, we think that it's going to be important. And if you have, we think that it's going to simplify locating the address of applications that are running inside of containers, of having another Azure-based communication bus, so that there's less configuration that every application needs to have around URLs of another application that I might need to call. So I do. We don't have that on the schedule, but make sure that you're getting ClearMeasure emails to get notification of that. So, all right. Well, thank you very much for your time. Again, if any of you are looking for help in either inspection of your architecture, your DevOps environment, your Azure environments, your the way your team is working, or just advisement anyway. If you are an architect or a lead engineer and you feel alone in not having a lot of peers to talk with, we have many clients where we just meet every week or every other week, and we just talk about what's going on and give advice as advice is needed. We love doing that too. Again, we don't want to take your project away from, there's plenty of development shops out there that try to pitch, oh, let us do your project. No. You're doing your project. You want to do it in an awesome way. and your company wants to have a rock solid software engineering capacity inside your company, that's what we want for you also. So that's why we do these webinars. That's why we teach. That's why we provide the Clear Measure way. That's why we give all these tools, and that's why we give templates that you can use for development team scorecards and our team alignment template. And if you are not using our Clear Measure way tools, then check those out. Send me an email with any questions that you have. Thank you so much for your time, and Merry Christmas. God bless.